السلام عليكم ورحمة الله وبركاته. أهلا وسهلا ومرحبا بكم. حياكم الله في دورة جديدة من دورات نادي هندسة الريادة بعنوان مقدمة في أساسيات الماتلاب، يقدمها المهندس محمد بلال، وهو أستاذ مشارك في قسم الهندسة الكهربائية وهندسة الحاسبات. ستكون الدورة على مدار يومين وحتكون أيضا باللغة الإنجليزية. Hello and welcome, Dr. Muhammad, and we are happy to have you here with us. You can start now. Dr. Muhammad.
Assalamu alaikum warahmatullah. Thank you for your nice introduction. So I welcome you all to this short course on MATLAB programming. So I hope that within this short duration of 4 hours, 2 hours per day, we will be able to cover the basics of MATLAB programming. So for this short course, we will not assume that you have any prior knowledge about MATLAB. We will start with, inshallah, the very basics. And during the workshops, while we are discussing, I highly encourage you to ask questions. If you do not understand anything, if you have any confusions or anything that you wish to clarify, so please don't hesitate in putting up your questions on the chat, or you could even ask using your mic. So let's start right away. So the basics of MATLAB programming. First of all, let's see what do we mean by MATLAB. So first of all, MATLAB is what we call the scripting language. So it is slightly different from your other languages which you may be familiar with, for example, C, C++, or Java. So they are what we call the compiled languages. So there is a difference between compiled languages and script languages. So in script languages, you could say that we write at a very high level, or we write close to our English language. While in C++ or Java, the code is many times it is more like a mathematical equation. So although in MATLAB, you will also be able to write equations, but at the same time, you will feel that the code is closer to our English language than to actually C++ or Java. Second thing is, why is it called MATLAB? So MATLAB actually comes from these two words, matrix laboratory. So matrix, as you probably already know, matrices are groups of numbers which we sometimes write like this. So for example, I will give you an example here. So 1, 2, 3, 4, for example. So this group of numbers is written in a square brackets in an arrangement which we call matrix. So MATLAB basically works on, it assumes that all the numbers, they are sort of they are a matrix, and then you work on those matrices. So that's why they call it a matrix laboratory, where we work on matrix. We process these matrices and we give the output as a matrices. So they took these two words, mat and lab, and then we call it MATLAB. So MATLAB is actually a very, very broad tool, you could say. It over the years, it has now included so many toolboxes in it that you could perhaps do any and everything that you may encounter in your engineering. And it is not just limited to engineering now. It is also being used frequently by people in the accounting, from the accounting domain, finances, people who work in stock exchanges, and just to so it has now actually become a very, very wide tool with just perhaps so many things that you cannot be maybe even memorize the number of commands they have included here. So since the goal of this workshop is of course the basics, so we will cover the basics, but we will do a few examples which are related to engineering as well. So in summary, you could say that it can be used for numerical analysis. Now, numerical analysis in our KU, we have a course 332, which is the numerical methods course. So in numerical methods, which is offered to all the engineering disciplines in KU, this course, if you have already taken it, you know that this is about implementing algorithms, those algorithms which could be utilized in any of the engineering domains. So if you are familiar with that course, or if you plan to do it, take this in near future, so you will find out that Matlab is an excellent tool for that. Matlab can help you build from the very basic algorithms to very advanced algorithms, and they can help you solve very complex engineering problems as well. And then these numerical analysis, these algorithms, although they are fairly advanced, you could do some simple matrix computations as well, which could be used for simpler applications. And if you want to maybe move on to even higher complexity topics, so you could do maybe signal processing, where signals could come from different sensors or mic or images, like images coming from a camera. So all of that could come into signal processing. And not just that, we could do also real-time processing as well. So what is real-time processing? Real-time processing is when we acquire the data in real time. It is being captured like a video, for instance, and you are processing it as you capture the images. You process some images, you find maybe the edges in it, you find some information about the image, or it could be also the audio processing, for instance. So over the years, Matlab has grown from simple numerical analysis or simple matrix computations to very complex real-time processing as well. And they have included toolboxes which could help you generate code for complex hardware devices as well. So for example, if you want to ultimately build your algorithm on a GPU, so Matlab could help you translate your Matlab code and help you generate the code for GPU, which is otherwise pretty complex to do. So however, the scope of this short workshop is minimal, so we'll be only doing some minimal numerical analysis or some simpler introduction to the Matlab environment and Matlab syntax. And of course, if you are interested in building an app for your program with a user interface, so Matlab also provides you facility with to build a nice graphical interface as well. And one other thing maybe I should mention here, that if you build an algorithm or build a numerical analysis algorithm for any of your engineering application, you could also deploy it on a for instance, an Android smartphone as well. So that is another level of graphical interface that you could have. So you can see that Matlab is now not just a matrix laboratory with simple computations, but it could help you do just so many things. And that's why it is a tool of choice for many researchers around the world. However, there is a limitation, big limitation of Matlab, and that is that it is licensed. So many commercial companies, if they afford to get the commercial license for Matlab, then they do that. Otherwise, a vast variety of you could say too many companies who cannot afford to have expensive Matlab license, then they go for other open source computing libraries, which are perhaps you can find it in Python. So you could say these days we have a sort of competition between these two, Python and Matlab. Python libraries, they are free, and you could do a lot of things there as well. But MATLAB, I would still say that if your ultimate goal is to stay in the research environment, then probably MATLAB is a better tool than Python. So we have already discussed that MATLAB is actually too broad. So if you say that this workshop is about MATLAB, so of course we cannot cover everything in this short course. So we are going to only cover the very basics of it. So we are only going to, you could say, scratch the surface. We will not probably be able to go into further details. So what you could do in MATLAB, simply, if you wish, you could just use MATLAB as a command line tool as well. For instance, like you use a calculator, for example. So you could say that MATLAB could be used as a glorified calculator, which with a lot of commands that are already accessible via simpler calculators. But on top of that, you could build graphs, you could do some more complex commands as well. So you could use MATLAB in this simple way as well. But then you could also use MATLAB to make scripts. This is where the real power of MATLAB comes in, because this is where you use MATLAB as a programming language, where you are not just running simple commands or running simple scripts, but you could write MATLAB, full-fledged MATLAB programs, which if you decide, you could ultimately put into, like we mentioned, put into work on GPUs or Android devices or any other hardware as well. And then you could store your data in MATLAB specific files, which we call the mat files. So this is generally this is the default storage files for MATLAB. Although you could also store your data in more commonly available formats as well. So for example, you could store images in JPG format. So that's a commercial or more commonly used format for storing images, or you could store audio files, or maybe for Excel files as well. But if you only want to work on your own specific data, then mat files are probably the easier way to store data. So in this workshop, inshallah, we will be using all of these things that you are just seeing right now on your screens, and we'll see how to make best use of these functionalities in MATLAB for our own purposes. So this is a very basic MATLAB screen. So when you first install MATLAB and you open this up and you click the MATLAB icon, so this is what you get. And you may notice that this screenshot is actually for an old version, MATLAB R2013A. So that was almost 9 years ago. But fortunately, MATLAB has kept this format for long, and they have not made many noticeable changes in this format. So even if you download and install the 2021 B version, which is the latest one right now, so you will notice that all of these windows, they are still like you're seeing right now. And since KU provides a academic license for MATLAB as well, so I think we should make the best use of that and definitely install the latest version and try our hands on it. So what do we have here? When you start MATLAB, it may start in the default library, in the default folder where you install the MATLAB, but you could change it to any other folder from this drop-down menu. So it is actually highly recommended that you start your MATLAB in a custom folder where you put all your codes. So that is probably the first thing that you should do when you open MATLAB. Change the current directory to the directory where you intend to work on. And then here we have the most basic command window. So this is where you could use MATLAB like a very advanced calculator. So if you type anything here, it is a typing interface. So you type your commands here and MATLAB will give you very quick answers to that. So of course this is a very limited view, but still this even this command window is much more powerful than the calculators that you generally carry with you. And if you want to maybe plot a few signals to see what they look like, or maybe want to do a few very basic operations on some simple data, then this command window is actually also very powerful. Then here we have another smaller window, which is with the title Workspace. So in the Workspace window, you will see your variables. So what are variables? Again, I'm not assuming anything. So when inshallah start working on them, so you will see that whatever we write on MATLAB, they are used. Whatever numbers you put into your command window, they are ultimately stored in a variable or in a data structure where you store the data. So that will appear in this workspace. So when you first start your MATLAB session, so you will see that this is all empty. But later on, when we'll start doing our processing, you will see that it will get populated, and MATLAB can make use of the memory a lot, and you could actually put you could store very large arrays of numbers as well. And like I was mentioning earlier on, you could even use images or audio files as well. So everything will eventually appear here in this workspace. And then here we have the command window, the command history. So in command history, it tells you which commands have you typed or have you run previously. And this command history will, unless you delete it yourself, it will keep on maintaining a history of your commands. And even if you close MATLAB and you start another session, this history will still remain there. But if you close MATLAB, then the variables here in the workspace, they will of course get deleted. So history will remain there, but the variables will not be. Right. So one of the, you could say, the most underrated, or you could say a feature that is highly helpful but rarely used by people, is this help one. So over the years, again, MATLAB has tremendously improved their help documentation. So if you are not if you are unsure about what to do with, you have something in mind but you do not know exactly the command for that, so MATLAB documentation or help window is actually very, very helpful in that. So if you have any vague idea of what you want to do, what you want the MATLAB to do for you, so you could just type there. And this documentation is offline. So that means when you install MATLAB, you can access this without even internet. But I will also recommend that if you have any questions related to MATLAB, you want to know something, some functionality about MATLAB, so I would actually recommend that you also search the same question on Google as well. So the very first links on Google, they generally come from the online documentation of MATLAB. So just include the keyword, first write MATLAB, and then type your question on Google, and the very first links, they will generally be related to, they will be coming from the MATLAB official documentation. So this, I would say that this is highly underrated, because people generally, instead of looking for help first on MATLAB, they look for other resources. So I would recommend that first you go with the official documentation and search for a solution, and then if you can't find the particular solution there, then only then you go for unofficial documentation, which you would find otherwise on Google. All right, so let's start with the very basics, which is the data structures. So data structures are, you could say, simply put, they are the variables that you use in any programming language. So we give them this generic name of data structures because, you know, in different applications, your the type of variables that you need, they could be very different. So for example, I was talking earlier about the images. So in images, the type of data structures that you would require are very different from the type of variables that you need maybe for when you are doing some audio processing, or maybe if you are doing some seismic sensors. So again, they will probably require a very different type of data structure. So that's why when we talk about data structures, we mean that what type of variables your programming language can store and how to access them. Now in C++ and Java, you are already familiar with maybe, for instance, the integer type data structure, or maybe the float type data structure, and then maybe also the character type data structures, and not just these, but also the arrays of it. So in MATLAB, you don't have to specially tell MATLAB to use any such type of variable at the start. MATLAB by default assumes that you are using floating point variables. And in floating point variables, again, there are two types, single and double, which we will inshallah shortly see in a while. So when you come to that, but by default, MATLAB assumes that everything that you are working on, that is a floating point data variable. So we will discuss more of it as we progress. So the first thing is the variables. We already saw that they are stored in your workspace, and by storing we mean that if you they are available only for this particular session. So if you close MATLAB and turn it on again, so the variables, they will not remain there, they will be deleted. So the workspace means the current workspace or the active workspace. So if you have any variable, any data structure in this workspace, it will be always available during the session. So maybe I should add the keyword here that they are always available, but only during the session. So if you close the MATLAB and again start it again, so your previous variables, they will not be available. So during an active workspace, however, active session, however, you can access them. Yes, is there a question here? Someone raised a hand. All right. So when you have multiple variables, or maybe hundreds of variables, for example, so a command that you could use is just type who. So this simple command will list all the variables that have been defined in your workspace. So for example, if you type who here, so MATLAB will tell you that these are your variables. But you could also take a just quick look at the variables in the workspace as well. So you see, this was the workspace. So either you could type who here to give you a list of variables, or you could just take a quick look in this window to see what variables you have right now. And then if you also do this who s, so this also tells the properties of variables. So like we were mentioning earlier on, that we have this keyword data structure because your variables could be of very different types. Images will have different type of data, audio will have different type, and then there could be just so many other types of variables. So when you type whos, it will also tell you what type of or basic properties of your variables. So for example, whos, and we see the variable x, that's the name of the variable. and it tells you the size of that variable. So now you see it says 1 by 1. So 1 by 1 means we have already decided, we have already seen that the MATLAB, the word MATLAB has the word matrix inside it. So mat is for matrix. So all the variables, or the very basic unit of the variable in MATLAB, that's a matrix. So it is telling you that it is a 1 by 1 matrix. So 1 by 1 matrix is simply just a number. Maybe, for example, this number was, let's say, 9.82, for example. So that's a matrix of size 1 by 1. So whether you write a single number or you write a full matrix, MATLAB will always treat it like a matrix, and it will say, yeah, so actually we have in mathematics, we call such numbers as scalar, but MATLAB will still call it a matrix of size 1 by 1. And then another thing to notice here is the bytes. So bytes is the number of bytes MATLAB is using to store this variable. So now you can see that MATLAB is using 8 bytes for this simple one variable. So why is that? The clue here is the class. Class is double here. So in the previous slide here, I was mentioning that in C++ or Java or in other libraries, you have to first define your variables. For example, it can be an int or a float or a character or whatever variable you want it to be. But in MATLAB, you just write variables names, and by default, all of them, they are floating point numbers. So for floating point numbers, there are two commonly used types, which are single precision and double precision. So MATLAB uses the double precision by default. So any number that you write, it is automatically, or by default, it's a double precision. So that's what you are noticing here. So this double precision number, one of them, it takes up 8 bytes. So for simpler programs, it may not be a problem, but if you intend to write a very large program with too many numbers, maybe thousands of numbers or maybe million numbers, for instance. So in that case, this could become problematic because each number is going to take up 8 bytes. And then depending on the memory available in your computer, you may run short of memory. So for simpler problems, this works fine. But when you go to higher problems or more complicated problems, so then maybe you will have to look into the basics of it as well. But for now, we are just going to deal with the very basic ones, which are the double precision numbers, which can hold any number that you wish to. And then some other very basic commands here. Clear all, it erases all the variables. So if you close MATLAB and then start again, it also erases all the variables. But if you don't want to close MATLAB and start again just to clear the variables, so this is the command that you're looking for. Then you can clear the window, CLC, so it will clear all the previous commands that are visible as well. And if you wish to save some of the variables on the disk, so you could use this save function. So this will save by default in the mat file that we were mentioning earlier on. So yes, Ziad has raised their hand. So do you have a question, Ziad? Okay, so the mat files are where your variables are generally stored. All right, so now that we know what are the variables, or you could say very basics of variables. So we have seen in summary so far that MATLAB by default stores everything as a matrix, which could be as simple as a 1 by 1 matrix, which is a scalar. And by default, it is a floating point number with double precision, which requires 8 bytes. So let's see how we can use that. So if you just open up MATLAB and type something like this on the screen, so MATLAB will give you the answer. Now, since most of you are from at least the engineering background, so you know what this type of syntax means. So of course, there are some simple arithmetic operations, for instance, this negative or this addition sign. And then we have this power sign. This is taking power of 2. So you could use this as a simple calculator, but with some more advanced, you could say, scripting lines as well. So what we have written here is, you could say, it's a very small script which is only based on numbers and no variables are input. So you type that and you get the answer like this. So MATLAB says that the answer is this. So now, since there was no variable as the input, MATLAB has, however, given the output as a variable. So let me actually do this on actual MATLAB window so that we get the idea of what we are doing. So this is the MATLAB window opened up right now. So if I type the command that is written here, so let me just copy and paste this command here. So you see MATLAB quickly gives me the answer like this. Answer is equal to this. So answer is now a variable that MATLAB has automatically generated. And if you look at the workspace here on the right side, you can notice that this answer variable has appeared and it has the value 0.0488. And let us do the command that we were earlier on doing. So WHO, who are my variables? So it says your variables are A and S, the answer which MATLAB has already given me. And then if I do who S, so it will give me some more information about my variable as well. So you see, like we were discussing earlier on, the answer is a 1 by 1 matrix, which is consuming 8 bytes, and it is of class double. So although I did not specify that use double, but MATLAB is automatically using it. So unlike C++ or Java, where you have to explicitly tell your variables, MATLAB automatically defines a class for it. Okay, so then if you are interested in doing some work on complex numbers, for instance, so this is next command deals with complex numbers. So 3 plus 4 iota, if I simply write 4i, so MATLAB automatically knows that this I means that this is a complex number. So I am multiplying this, I put the multiply sign, and I multiply this by another complex number, and you may notice that this is actually the conjugate of this complex number. So when I multiply these two together, it gives me the answer as 25, which is a real number. But if I just do maybe addition of two complex number, and the second complex number is maybe 3 minus 8 iota, so the answer is 6 minus 4 iota, which is a complex number. So this is how we can use MATLAB as simple calculator, where we put everything in the command window and we get a very quick answer. You could also do, of course, cosine of pi by 2, for instance. So pi is again a common variable that is used in engineering. So MATLAB has a dedicated value of pi built into it. So if you just write cos pi by 2, so that is pi by 2 is 90 degrees. So MATLAB, you know that cos of 90 degrees is actually 0. But MATLAB gives me an answer which is 6.1232 e to the power minus 17. So, you know, this is actually as good as 0. So this is a very low value which is approximately equal to 0. So this could happen as MATLAB, instead of giving you an answer which is exactly 0, the answer that you are getting is actually a number which is pretty close to 0, but not exactly 0. So why is this happening? Because MATLAB also is making use of some algorithms inside, and they when you write the when you put out the answer, so mathematically speaking, they will not be strictly speaking 0, but a number which is as close to 0 that you could call them a 0. The command window that does not change. So I'm sorry, I don't get the point. What do you mean by does not change? Your variables will not change unless you specifically want them to change. But if I close MATLAB right now and start it again, so my ANS variable that is here on the right side, it will go away. So again, if I just want to print the value of, let's say, pi, so I just write pi here. So now it prints the value of pi as 3.1416. So by default, the number of significant digits that MATLAB is showing me, or you could say the number of digits after the fraction, is four digits here. But if you want to show more digits, so you could go into the preferences and you could change that up in this case here as well. But let's not maybe go into that right now. So actually there are many options here as well. So we are not going to change any of the default ones right now, because these default ones, they are pretty easy to use, and they work for most of the time. No. If I close the program, the history will remain the same. So let's see what will go away and what will not. So let me write something like this, that I make a variable pi value, and then I write it like this. So now you see on the right side on the workspace, now I have two variables. One was the previous value of, because if I don't write a specific name for a variable, so MATLAB automatically puts that in a variable which is the answer, short for answer, ANS. But if you write something like this, pi underscore value, now I have given it a name myself, and I say that this value should be pi. So now you see on the right hand side, I have two variables, ANS, which also has the value of pi, and pi value, which is also pi. So if I now, yes, so why is cos pi by 2 is 0, and why is it not exactly this? So you see 6.23 into 10 to the power minus 17 is actually as good as 0. So why is it not exactly 0 is because how this cos is being calculated. So if I write something like this, for instance, if you're concerned why is it not exactly 0, so if I write something like this, round cos pi by 2, so you see now you get the answer 0. So MATLAB has rounded the answer to the closest value, which is 0. So why am I not getting the exact answer 0, and why am I getting a small value? That has to do with the way cos is actually calculated. So that is something that we will towards the end of this workshop, we will see, inshallah, we will see some examples where we will write our own algorithm for finding the value of cos. So the real answer will come there. But this number, as engineers, as mathematicians, maybe you are not comfortable because this is not exactly 0. But as engineers, this value is as good as 0 because this is a very small number. But when you are using computers to find answers, to find cos, sine, or tan, so you must understand this, that these numbers, they are calculated through algorithms, and the algorithms, they have limitations. They do not, so even if you want an exact answer as 0, but you are getting a very small number. So this is what in practice things are. So we will, so keep this question in mind. till we actually come to an algorithm where we can find the actual value of cos using a program. So for now, we are only concerning ourselves with the variables and how to store them. So which part of it will remain like this and which will not remain? So for that, let me just close the MATLAB window, and I'm going to start this again. So it may take some 30 seconds to start. So in the meanwhile, let's just look at some other things that we were discussing here. So cos of pi, it is not exactly 0, but for all practical purposes, for now it is 0. Then you could do also something like this. So this is, if you want to write it as an equation, it will look something like this. exp is of course the exponent, and then a cos is arc cos or cosine inverse, and then we are inputting 0.3. So going from a mathematical equation to an actual programming script, of course, requires some learning to do as well. So you will have to memorize that exp basically means e to the power, and a cos is the function, which is a short form of arc cosine. Arc cosine is inverse cosine. So arc cos is inverse cosine, and this is how you write that down. So of course, with every programming language, you will have to memorize a few things, but you may, if at any point you are stuck or something, so again, like I advised you before, make good use of the help document. So if you are not sure how to write the exponent function, just type on MATLAB help window exponent. So let's do that. I think by this time we have MATLAB opened up. Yes, here it is. So you see, I closed the MATLAB, and my variables, previous variables, they are all gone. Actually, my command window is also it is clean. But if I want to access my history, so I'm now going to press my up arrow. So if I press my up arrow, now you see my history is now available. So which command from the history I want to run right now? So this is the time at which I started my my MATLAB session this time. So these are the commands that if I keep on pressing my up arrow, so I can select an exact command from this session, which I would want to maybe run again. So maybe I want to run this command again. I type this, and now the variable has been again, it is now again available in the workspace. So after restarting MATLAB, my command window will clear out, my workspace will clear out, all the variables will be gone, but my history will remain there. So if I go up, further up, you see this was the time, this was yesterday when I was doing something else. So at this time on 18th February last night, I was doing this another MATLAB session, and before that, some 2 days ago, I was doing all of this. So this is keeping the history of everything. So if I want to run something again, this is a quick way of doing it. So just press your up arrow and it will give you all the command history. So this is also very helpful in various scenarios. But if you want to save your variables, then you have to explicitly save them. Otherwise, they will not be available. So how to save them? We will cover that inshallah just now as well. So coming back here, these are some very basic mathematical operations: cosine, sine, arc cosine, or exponent. As engineers, I hope that you already are familiar with all of these. But of course, there will be some syntax, like for instance, this a cos. So you will have to know how to write that in MATLAB. But let's say you are not familiar with that. So let's go there. Let's type in the documentation cosine. So let's see what MATLAB tells me. This is the documentation, and you see the very first thing that I get is sine cosine. Let's go there. and it is telling me all the details of that. Implement fixed point. Fixed point means that it is like your floating point, but actually this is a slightly advanced topic. It is limiting the bytes it is using for sine and cosine. But simply put, let's not go into the details of that. So simply put, it is implementing sine and cosine. And then there are actually various versions of it as well. So let's maybe search another version of it. So if I type maybe half of that, so sin. So now I get multiple hits for this sine function. And it actually says 350 modes because the sine function is implemented in various ways. So most simplest of them maybe is this one, which it says in the Matlab. So let me click that. This opens up another help window, which is, I think, what we are probably looking for. So y is equal to sine x. And then it also tells us maybe how to plot that function, which we'll inshallah shortly do. But if you look at it, so it is giving you a lot of further details as well. So one important detail here is the input argument. And it says that the input angle in radians. So by default, Matlab takes in inputs as radians, not as degrees. And the output is the sine of the input angle. And then another thing that is important in help is that towards the end, it also says something like C also. So something related to sine. So for instance, there is a function which is sine D. So let me open that in the new tab. So sine D is actually the same as sine, but the argument can be in degrees. So let us quickly check this. We want to find the sine of 90 degrees. I write sine 90, so it will give me sine of 90 is actually, it should give me a 1 here, but it is giving me 0.894. And why is that? Because it is expecting the input argument as a radian. So instead I should use sine D. And then I get the actual answer, which is what I'm looking for. So coming back to this help document, I was mentioning here that this help document will contain actually a lot of things that may be used for advanced usage of this function as well. So for instance, I was mentioning earlier on that you can use Matlab code to generate, to program your GPU as well. So this is what you see. This is if you use this function, so it can be used to generate code ultimately for a GPU. So this is strictly beyond the type of thing that we have to do in this short workshop. But the purpose of showing you this screen is that whenever you are unsure about something, so just type. Matlab help is actually quite helpful there. So if you are still not sure that if you got the answer or not, so then go look for C also, and there you may find something that you need. So for example, you type for sine, but you are actually looking for arc sine. So you see the C in the C also, the second tab is A sine, which is the inverse sine. Similarly is for cosine as well. So in this example here, we were using actually not here, but here we were doing A cos. So how do we, if you are not sure what is A cos, or you did not have exposure to this Matlab function before, so just type cosine here in Matlab. So let's see what it gives me here. So let's just go to cos, and this is the cos function. So let's go to C also, and there it tells me there is a function cos t, A cos, and then A cos t, and then cos hyperbolic as well. And then there is yet another one, which is, so let's see what is cos hyperbolic cosine. And then there was another one, and you see another one here is radian to degrees. This is a function which you could use to convert angle from radians to degrees. So let's do that. Let's quickly put that to use. Radians to degrees. So if I write, let's say pi by 2, so pi by 2 is 90 degrees. So it gives me the answer like this. Pi by 4 is 45 degrees. So Now something tells me that there will be also a function which should convert from degrees to radians as well. So another way of accessing the help is you type something here. So I have a hunch, I have a guess that maybe MATLAB must have a function degree to radians. So I type degree and then I press tab here. So MATLAB now tells me that there are two functions here which could be used here. So degree to radian. So my guess was right. I just press enter and now I write 45. So 45 degree should be now converted to radians, and there it is. This is radians. And I could also type here as well, help cos. So if you type help here, so there is a quick help available here as well, which will print the help here. So then there it is also telling me see also a cos. So let me click this a cos. It gives me the help for a cos as well. So you could do Google search and click on the MATLAB links, or you could write help related to whatever you want to find. So let me type help cosine. Let's say I was not familiar with the function cosine. So I just write help cosine. It says this is not exactly available here. So go to the documentation, which opens up this one, and there type, start writing cosine here, and we get that. So I heavily encourage all of you to, whenever you have anything that you don't get. So MATLAB help is pretty expensive, expansive, and it covers everything, and you should really make good use of it. And if you can memorize part of the function, so for example, this cos function, so you write some part of it and then press tab, and there you get, there are actually so many functions that you could use. Cos, cos t, cos h, and then there are some more complicated functions as well, which I think are not even related to this simple cos. Right, so this is how you do simple MATLAB as a calculator. But now we would want to also put these things inside variables as well. So we have already done that actually. So I could write something like a is equal to, let's say, 45. Now, one important detail here is that you may have noticed that I have put a semicolon here. I could write this without a semicolon as well. So if I write this without a semicolon, so there is an immediately a difference here. So when I write a is equal to 45 with the semicolon, a variable is generated. You can see that in the workspace. If I do the same thing but without the semicolon, so same effect is same, but MATLAB also prints the value of a again. Although I have printed it myself here, but MATLAB also prints it again. So let me do another one. Let's say b is equal to cos d of let's say 75 degrees. So I do that without putting the semicolon. So now you can see it has, MATLAB has printed the value of b, which is 0.2588, and you can also see this in the workspace as well. If I click this here workspace, I can further inspect it. So this opens up a new window, and it is only a one variable with the value 0.2588, and it says that this is one by one row, one column, and the type is double. So this is how you use MATLAB as a very simple but glorified calculator. You can do a lot of things here on the command window, and it is still much more, you could say, user-friendly than using a simple calculator. And like all other mathematical equations, it will always help if you put as many brackets as you can. So for instance, here it was recommended to use brackets as many as you can, because it will help you write neat code. So for example, if I write exponent of let's say cosine of maybe arc sine of some number, let's say 45. So of course I have to write a lot of brackets here, and the answer is a complex number. And how do I know it's a complex number? Because of this iota here. Right, so now let's move on to slightly more complicated data structures, which are arrays and matrices. So this we have covered already, that MATLAB by default, it will say that this is a 1 by 1 variable, 1 row and 1 column. And the answers are like that as well. So you can add them, subtract them, take sine, cosine, do any sort of operation that you want. But then you could also make row vectors or column vectors. So if you want a row vector means that it has 1 row, but it has, let's say, 3 columns. So mathematically we call it 1 by 3 vector. So we don't call it a matrix, because if one of the rows or one of the column is 1, so we generally like to call it an array, not a matrix. Then similarly, here we have another vector, but we call it a column vector because it has 3 rows, but only 1 column. So this is again a vector. So how do we write this in MATLAB? We simply make use of these square brackets. And if you write it like this, 3 space 1 space, so it will give you a row vector. Sometimes for clarity, we can also put commas here as well. But whether you put a comma or you put simply space, MATLAB will give you a row vector like this. But how do we define the columns? How do we go to the next line? Because here everything was in 1 line. There was only 1 row, so 1 line. But if you want multiple rows, then you have to put the semicolon. So semicolon tells MATLAB that this 3 is in the first row. Semicolon means next row, and then 1 goes to the next row, and then another semicolon means we are going to the very next row, and then this 1 goes here. So this is how we define the row vectors and column vectors. And then what about the matrices? Matrices have generally both rows and columns. So let's define a 3 by 3 matrix. That means 3 rows and 3 columns. So first we write 1, 2, 3. So this is the space in between. So 1 goes here, 2 is the second element, 3 is the third element. And now we want to go to the next row. So we want to define a next row. So we put a semicolon here. So that tells MATLAB to go to the next row. And then we similarly put 3, 4, 5, which goes here in the next row. And then another semicolon, which tells MATLAB put another row. And this is what we get here. So let's put this to practice here. Let's define a matrix. So let's have y is equal to, start with the square brackets. Let's put maybe 4. Then I could put a space or I could put a comma. So both are fine. So let's put a space right now. So 4 space, maybe 5.1, another space, then maybe 9.1. Let's define a 4 by 3 or 3 by 4 matrix. 3 by 4 means 3 rows and 4 columns. So that means I have to put another one here, 1.2, let's say. So there are 4 elements here in the row. Now you see, due to the space, maybe this is not very clearly visible. So that's why a comma will help you differentiate between different elements as well. So sometimes a comma is, you can put just for clarity. Then I put a semicolon that tells MATLAB go to the next row. So now let's have maybe 2.2, another 4.3, then 5.1, and then 6.2, let's say. So in the second row, I have not put any comma because comma is optional. So let's close the brackets, and this should give me a 2 row and 4 column matrix. And this is how it is shown. So I had not put the semicolon at the end. If I put the semicolon at the end like this, so MATLAB will define the variable, but it will not show us immediately on the screen. So if you want to clearly see the matrix as well, or the whatever you have defined here, so don't put the semicolon here. So it is an automatic way of displaying it. So if I have not displayed it here, so how do I know if it is working, if it is indeed the matrix or not? So you could always go to the workspace on the right, click this Y, and this is the other view of the same matrix. A more, maybe a clearer view, because it is showing you that this is column number 1, column 2, column 3, column 4. And if you click here, row number 1, row number 2, and so on. Column vectors in several lines, not in single line. Several lines, that will not be possible. Or you could say it is possible, but it will be a bit more difficult. Let's say, okay, let's write it like this. So let me clear everything so that we start from the very basic slate. So let's clear everything. So clear all, remember, it clears all the variables. So I'm going to type this clear all, and you see on the workspace, all the variables are now gone. And you know, this screen is, let's say, also bothering me, that this is all commands. So let me type CLC. So this will clear the screen as well. So now this is like I have just opened up MATLAB. So the question is, can you type this in multiple lines as well? So it is possible, but you may find it a bit more complicated, but sometimes useful. So let me write it like this. So what we are going to do is, let's maybe use the same example. So initially I will just define A is equal to 1, 2, 3. So let's do that. So A is equal to 1, 2, 3. So now it is a row vector. But now I want to, let's say, add this row as well, 3, 4, 5. So what I do is, A is already defined here. So I make another variable B is equal to square brackets A. So I'm telling MATLAB that the first row is A. A already contains 1, 2, 3. And then I put semicolon. And in the next line, what do I want? 3, 4, 5. So I write 3, 4, 5. And now you see I have made another matrix with 2 rows, and they were done it not in a single line, but in multiple steps. And then I could also have the last one as well. Let's also put the last row 6, 7, 0. So for that, let's define C is equal to B is already defined for some partial matrix. I put B and then semicolon, go to the next line, write 6, 7, 0. 6, 7, 0. So I think this is what you were asking for. So actually, sometimes you may want to do something like this, but in some other ways. So can you write it as a sequence? I'm not sure, what do you mean by sequence? If you mean by sequence, maybe let me clear everything again. So if I write, there is a MATLAB command which you could write something like this: 1, 2, let's say 5. So 1, and see, I have put a colon here, not a semicolon, but a colon. So 1, 2, 5. So MATLAB now gives me this 1, 2, 3, 4, 5. So I think maybe this is what you were asking for, because this is like a sequence of 1, 2, 3, 4, 5. So going by a step of 1. Actually, you could get the same thing and you could write it like this. So what does this mean? 1 colon, and then I put another 1. That another one tells MATLAB that use a step size of 1 and go till 5. So it is giving me the same thing. So whether you put a 1 or not, it is actually, yes, that's the step value. So if I change it so that, let's go 1 to 10, but use a step of 2, let's say. So then it is 1 step of 2, which is 3, 5, 7, 9. So so you could do something like this as well. This is exactly what we intended to do in this slide, and not just any, you could say any sequence. You could specify, you could even use negative numbers as well. So for instance, we could have b is equal to, go from, let's say, -9 with the step size of 3, go up till maybe 12. So I get a row vector which is starts from -9, as this was the start value. Take a step of 3, so -9 plus 3 is -6. Then with a step of 3, I go all the way up to 12. But what happens if I put the range as the last value as 11, let's say? So we can see that 11 was the last value. So after 9, it was supposed to go to 12, which will violate this last value. So that value is now not included in that. So we have seen that the square brackets basically tell you that you are going to now write either a vector, a row vector, column vector, or a matrix. Then another very useful function is this rand function, random number. So random numbers are required in a variety of applications in engineering. So if I want to, let's say, get just a one simple random number, so I just write it like this: r is equal to rand. So I will get a random number which is 0.8147. So if you want to see some further help on it, so let's just type help rand. And what do we get? Simply put, r is equal to rand returns an n by n matrix. So here we see we did not use any input here. We just typed rand. So by default, it means if you don't give any number here, so it means 1. So we were given a 1 by 1 number here. So anyway, it gives us a pseudo random value drawn from the standard uniform distribution on the interval 0 and 1. So I will not go into the detail of pseudo random. What is a pseudo random? Basically, when you generate numbers through a computer program, that is a pseudo random. Then standard uniform distribution, again, in your probability course, you may learn more about it. But for us, for now, it is important that this number gives us a value between 0 and 1. And if we want more of these, so I want maybe 4 by 4 matrix, all consisting of random numbers. So I get this. If I want maybe a 2 by 3 matrix, so 2 rows and 3 columns of random numbers between 0 and 1. So I type something like this. So this is what I get. Then another function that is related to this one in terms of functionality is zeros and ones. So let's have a variable z is equal to zeros. So let's have maybe 5, 6, 5 rows and 6 columns of all zeros. So I'm putting a semicolon here so that it does not print the value here, but I can go to my workspace and see the matrix here, and there we have it: 5 rows and 6 columns, all of zeros. Then I could have also ones. So I could have O is equal to ones. And how many ones? Let's have 25 rows and maybe 50 columns. So now you see this is going to be a very large structure. And if I don't put a semicolon, what will happen? It will basically fill up my screen. It will display all the ones here. And you see, let me do that. So you see, it will quickly fills up my screen because I was printing it. I did not put a semicolon here. So since there was not enough space, so MATLAB does this by parts. It will first show me columns 1 through 14, then 15 through 28, and then 29 through 42, and finally 43 to 50. So that's why it is important that if you have very large data structure, so always put a semicolon so that your screen does not get polluted and maybe your previous values will get, they will go up and you will have to screw them. So let's put it like this. And you want to see them, go to Workspace, click this, and this is a neater way of seeing what you got here. I could similarly do some random numbers as well. So let's have random values, and how many of them? Let's have 1000 by 4000 ones. So 1000 rows, 4000 columns, all random numbers. Let's see what do we get here in the R. So you see 4000 columns and 1000 rows. So if you have large matrices, it is a good idea to see their values from here instead of just simply displaying their values on the main window. Okay, difference between rand and random. This is a probability question. So their distribution, you could actually do a quick help rand. So we did that. Help rand is, it says standard uniform distribution. But if you do rand n, it says standard normal distribution. So the difference is uniform distribution and normal distribution. So what's the difference between uniform and normal? I will leave that for you to find out. This is a probability question. Okay, so what are the applications of zeros and ones? Yes, excellent. Why do we need zeros and ones? So sometimes we need all the matrices of a particular value, for example. So if I want 1 to 7 by 1 to 7, let's say, I want a matrix which should have values all filled up with 1 to 7. So let me get this ones, 3 by 3, and I multiply this by 1 to 7. So I get a matrix which is all filled up with this one. So in various algorithms, we need sometimes a whole matrix which is filled up with some constants. Same goes with zeros as well. Sometimes in initialization, when for an algorithm, initializing with the zero value is a very common scenario. One other thing that you could do is which is called the identity matrix. So if I write I, for example, EY, so it gives me a matrix which from your math course, you may remember that this is the identity matrix with all ones in the diagonal and all the other values, they are zero. How do we delete rows? Excellent question. Yes, let's do that. So we have this, let's get a random matrix, rand. Let's get maybe 3 by 4. So 3 rows, 4 columns. So let's delete the second row. So how do I delete the second row? Before we do that, actually, first we should remember, yes, so they are both actually relevant questions. So first we need to access particular element. So let's say I want to access this element, 0.8067. So where is it? It is in the second row and second column. So for that, I will have to write something like this, R, put square, instead of square brackets, write round brackets. Second row, comma, second column, put, close the brackets, and you see the answer is this, 0.8067. Then if I want to, let's say, access this element, so what should I write? I want to access 0.9576 here. Yes, so second row and third column. So row comes first, row is first, column is this one, and I get this. Then if I, let's say, want to display the whole of second row, this one. So R, second row, and all columns. All columns means I could write something like this: 1, 2, 1, 2, 3, 4, all of them. So this is how I display all the row here. But there is a shortcut way of doing it as well. Instead of writing all of them, simply put column. That will also give you, that's a shortcut. So now the question was that, so now we know how to access this. So also let's maybe access the second column of it. So all the rows 1, 2, 3, and only the second column. So you see, I get this value here. Let me display the value of R so that we know we are getting it again. So this was R, and the second, this one, what does it do? All rows 1, 2, 3, and second column. So second column is this one, 0.0931, and this one. So now we know how to access rows and columns. So now we want to delete it. So we already have this selected here. Let's put this to empty. So empty brackets. So okay, so this is not working. On null assignment on a non-column index. Yes, yes. So maybe if I do something like this, yes, yes. So if I select all of them, if I put numbers, then it doesn't work. But if I just put the shortcut way of doing it, just the column, and then put this equal to empty, then it is gone. So you see, whole of the second column here from this R, it is gone. And then if I, in the new one, R is now new one. So if I now delete the third column is the last one. If I do this, you see now the third column is also gone. And if I now want to maybe delete the second row, so second row, all columns, so that is also gone. So this is how we can access individual rows, individual columns, and individual elements as well, and then we can also maybe delete them using this empty operation. You can actually replace it with your own numbers as well. So let's say now we have this R again. So for the second row, let me replace this with my own elements. So 1, 2. So now you can see the first row is as it is, but the second row has been updated with a new row which I provided here, which was 1, 2, and it has been done now. And similarly, I could replace the column as well. So let's replace the second column with maybe, let's say 3, 4. So now you see the second column, which was earlier 0.28 and 2, now it is replaced by 3 and 4. Right, so now you are familiar with basic row operation, column operation, and how to change them, delete them as well. Can I replace with the matrix? Yes, of course. I mean, if you want to replace a whole matrix, then I don't see actually the point. If you have, let's say, another matrix, so I could simply write R is equal to maybe another matrix, maybe 3, 5, 6, 7. So yes, of course, I mean, R has been totally changed to any other value. The smaller one, or R equal to the new R. Yes, so when you replace that value, then of course the new is written. And bigger one and smaller one, actually, if I write it like this now, R is equal to a new matrix like this. So yes, so the previous value of R is gone, and now we have this new one. But one thing you have to make sure that when you are doing the row operations, the number of rows should be same. So for example, you see here we replace the whole row with something like this. So let's try to do the same thing here. R whole of second row, all the columns, and let me try to replace them with this 3 and 4. Now you see the row has actually 4 elements, but I am supplying only 2 elements. So Matlab will complain. MATLAB will say that unable to perform assignment because the size of the left side is 1/4, as expected. This is second row, which has four elements here, and the size of the right side is 1/2. So yes, pretty obvious. So it doesn't get implemented. So what I can do, however, is that if I do something like this 7, 8, so now this is possible. So whenever you are doing row and column operations, make sure that right hand side and left hand side, they are same. So you could also put, instead of just numbers, you could also put maybe operations inside this. So for example, here, when we are making this row, first element is a direct number, immediate number. Second is square root of -7, which is a complex number. And then you could also put expressions as well. And like we were doing here already, you can access each member individually as well. You can change them as well. And you can replace the whole array as well at the same time. And one more thing is that you could also do a more, you could say, without, if your arrays are manageable in size, smaller arrays, so you could change the values here as well. So for example, let me delete this value and let me put, let's say, 4.5 here. Or maybe here, let's delete this, maybe 5.677. So you could do this kind of simple manipulations here as well if your matrices are small. Of course, when they are thousands of values, so then you should, if there is a need for changing values, you should do that programmatically. So zeros, ones, and randoms we have already covered, and all three, they are used in various algorithms for doing various tasks. So again, coming back to the data types, so far we have seen that all our numbers, they were of type double. So whenever you have a number here, we are dealing with the numbers. So by default, they are floating point. That means you can put fractions, or so they are the most general type of numbers. And also MATLAB uses double precision for that we also see. And they could be real or complex, both. So this is the default. So when you type any number, it is by default a floating point number with double precision, which uses, as we saw earlier, it uses 8 bytes. So if I have a, let's say, random number, let's say of 10,000 size in rows and columns, both of them. So now you see, this is a 10,000 by 10,000 array, matrix. So 10,000 by 10,000 is a large number. That means there are a total of 10 is to the power 8 numbers, and each one of them is double precision. So you see, it is double by default. So that means if I write it here, so it will be 10,000 times 10,000, and each one of them is 8 bytes. So this many bytes are required. So that is how many bytes? This is roughly K, this is roughly mega, and then 0.8 giga. So you see 0.8 gigabytes roughly. So that's a very large array. And my laptop RAM is roughly 16 GB. It is, I think, 16 GB. So it is consuming up to 1 GB of that. So that's fine. MATLAB can do that. There is no problem. But when I store it, let's say on disk, so let me do that as well. So while we are here, so I could right click this and I could save it as. So I could give it my number, my random numbers. So let me just save it there. Now you see it is taking up some time. And why is that? Because it is writing this on disk, and on disk it is writing 1 gigabytes of memory. So that is a lot of memory. So what we could do is, if I don't require this much precision, so this is 1 gigabyte if I am storing those numbers. So I could choose single precision. Single precision only takes 4 bytes per number. So that is half of that. So if I store the same array here, but using single precision, so it will take 500 MB, half of the disk space that is required there. So it has been written there. So let's see the size on disk. See, it is actually 7388 something right, slightly less than gigabyte, because in computers the actual memory is 1024, not exactly 2000. So 1024 by 1024, that's the mega. So it is divided by this. So still a very large array, and I probably don't need this much precision. So if I, however, use single precision, then the size will be reduced. So if how do I tell MATLAB to use single? I can do something like this. I say ran the same function, but I write single. And now you see here it says single. And now if I try to save it, save as, let's overwrite that same number. I says want to replace it, yes. So this will take up half of space, but still it is floating point, so I need that. But sometimes I don't need floating point numbers. For example, I don't have fractions like 0.45. I don't have this. I have only integers like 1, 2, 3, 4, 5. In that case, it is more advisable to store it as integer. Integer again has multiple types. For example, you could have int 16 or you could have int 8. So if your numbers are, let's say, only between 0 and 255. So if you're maybe already familiar that images are stored as 8-bit numbers like this. So they can be stored as int 8. But if you have bigger numbers, so maybe then you can use int 16. So int 6, this is 1 byte and this is 2 bytes. So this is 4 bytes. So you see, if your numbers can be represented in 16 bits, so it will be then further advisable to use int 16 for your purposes. So if you're depending on your application, you may want to change the scenario, but by default MATLAB uses the best possible representation, but that is also very heavy on the memory. So I think it has been saved. Let's see the size here. So you see the size has been now, earlier it was 700 something, now it is 351 MB. So half of that size. Let's also delete that. Right, so this is some further advanced things if you run into memory problems. Then not just numbers, you could also have logicals. So what are logicals? Binary numbers with 0 and 1, true or false. You could also use that. And you could also put character strings. For example, if you want to store names of a few things or English characters, so you could do that as well. And then there is a more complicated things which are called a symbolic math. So for example, you want to do integration of, let's say, x, a function here. So MATLAB can do symbolic integration as well. So this is a slightly advanced topic which is used in this symbolic toolbox. Right, so we have now discussed that by default it is double precision, but if you run into memory problems, then you may want to change that. So whenever you define a variable, by default it is like this. Then you could also make arrays, cell arrays, or advanced data structures. So again, this is a slightly more advanced topics, which probably we may not have time to discuss right now, but simply put, it is like the object-oriented. If you are familiar with Java, then in Java, we have object-oriented programming. So a similar type of thing could be done in MATLAB as well, but that is again slightly more complicated. So these are more details of the same thing that we were discussing earlier on, that by default it is double, but if you run into memory problems, then you may want to change to single precision first. That will reduce the requirement by half. And then even then, if it is more for you, then you see that if your task can be done through int32, that is still actually 4 bytes, because 32-bit is still 4 bytes. So in terms of memory sizes, they are same, but in terms of computation, sometimes this is faster. So you should consider these other data types when you run into 2 types of problem. One is memory, you run out of memory, or you feel that the algorithm is running slow, because double is, although it gives you the best precision, it is also the slowest, and it also takes up the most memory as well. Okay, so numeric data types, we have already discussed that whenever you enter that, it is already a double number, and that is the IEEE standard of double data type. So what are the max and min number here? So real max and real min, these two tell you the absolute maximum number that you can store. So you can see that this is actually a very high number. 1.8 into 10 is power 308. That's a really large number. And similarly, the minimum number is also this much. So most of your engineering applications, they generally don't require such high values, but MATLAB anyway provide you with this such a high range. Okay, so I guess we have done most of these things here already. If you are further interested in knowing more data types, so the lecture slides will be available. You can go over it once again in your free time, and if you have further questions related to this data type, so we could, of course, discuss them in more detail there. So how about storing characters? Because sometimes you also need that. So the MATLAB way of storing characters is something like this. You put the single quotes like this, and now you have a variable that is not a number array, but a string array or a character array. So you can see that here. If I click it here, it tells me that this is a character array. Character means each one of this is an English character, and the size is 1 by 5 again. Why 1 by 5? Because there is one row and there are 5 characters in that, so each one of this is a column here. So again, if you want to access it like this 1 by 3, for example, so you see it has accessed the first row and third column. So third column was an L, and you are being displayed this L here. So you could use numbers as well as strings or characters in your code. But if you try to concatenate them like we were doing earlier on, we were adding more rows and deleting more rows. So if you try to do this on the character arrays, you have to make sure that the rows and columns, they are same here. So you see this one has 5 characters, and here it has 1, 2, 3, 4, 5 here. So these are two fine, they can be concatenated. Hello will go in the first row, world will go in the second one. But this one is the problem. And why is it a problem? Because it has 1, 2, 3, 4, 5, 6, 7 characters. So you cannot have in a matrix, you cannot have 5 elements in the first row, 5 in the second, and then you have 7 in the third row. This cannot be done. So that's why this is an illegal operation here. Okay, so this is some very basic operations there, and since we have to finish up in next 10 or 15 minutes, let's see what are the most essential things that we should discuss before I give you a small assignment of the sorts, so that we can discuss that later on. So I think these are some very basic things that we have already gone over it, but this logical operation, they may be, we should discuss that right now. So logical operations, true or false, logic ones. So let's say if I write an array, which are, let's say, something like this, 1, 2, 3. And then I write another array, which is maybe -1, 5, 1. something like this. So these are two arrays, A and B. Now, if I write a syntax that goes like this, C is equal to A less than B. So A less than B means that I am comparing each element of A with the corresponding element in B. So what do I get now? I get a logical array. Logical means 0 or 1, or yes or no, true or false. So we see the first element of A is 1. First of element of B is -1. So when I write A less than B, so that is a false. 1 is not less than -1. So I get correspondingly a 0, which is a false in this logical array, which is the output. Then next element 2, 2 less than 5, that's correct. So I get a 1 here, that is true. Then 3 less than 1, that's again false. So I get a false here. So logical array is another type of array that you could get in Matlab. So 0 is false and 1 is true. So not just rows and columns, you could actually have in Matlab a third dimension as well, which you may not be able to visualize, but that can be there. So for instance, I could have, let me again clear everything up. So let's have random numbers, 2 by 2, or no, let's say 2 by 2 by 2. Now what does that mean? 2 by 2 by 2. 2 by 2 was fine, two rows, 2 columns, but what is then this another 2? So this is the third dimension, which you cannot visualize. So 2 elements by 2 elements, this is the first, you could say, the first, what should we call it, the dimension of that, and then the second dimension of that. So this is a 2 by 2 by 2. This is a third dimensional element, which in order to represent this in numbers, you will have to look at it like this. You can actually even not maybe plot or make a figure out of it, because visualizing 3-dimensional figures is actually difficult for us. And if 3 by 3 is difficult, then what about the fourth dimension? Fourth dimension will actually be even more difficult for us. So if you try to visualize this, it is a 4D element. So in Matlab, you could have arbitrary number of dimensions, not just 2-dimension or 3-dimension. You could have arbitrary number of dimensions here. So you could call them as that rows and columns, and then you could, for the third dimension, you could call them pages. But if then there is a fourth dimension as well, so maybe you could call them, I don't know, you could call them books, just to be consistent with this thing. And then if there is a fifth dimension, you could call them a library. So, mathematically speaking, there could be any number of dimensions. Depending on your application, they may have a meaning or they may not have a meaning. Yes, so if, yes, we will inshallah stop at 6:20 within 7 minutes. Right, so you can have any number of dimensions. Matlab allows you that, and it may have a different meaning in different contexts here. So you could also have multiple in a single. You could have a object-oriented programming based thing as well. So for example, you could make a data structure, which you could say a dot. You put a dot here, which is like a Java-like structure. A dot name is some name here, Shehzad, and then a dot ID, which could be a number. So it could become a object-oriented program as well. So again, if need be, we will revisit this idea. Otherwise, strictly speaking, to make our algorithms, we don't need that right now. Then if you divide something by 0, of course, you will get an infinity. That is to look out for if you somehow your algorithms runs into this kind of problem. So you could have this erroneous result as well. And if you do 0 by 0, then you would get a not a number error as well. And accessing in each and every element of an array, we have already discussed this part already. So basic operations, plus, minus, multiply, this we have already discussed. Let's quickly go over one quick detail that I want to discuss before we leave for today. So let me clear everything up. Right, so let's make an array X let's go make it go from 0 to, let's say, 10. So these are all element values from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I could assign a new array y, and let's do an operation of it. So let's call this x power 2, that is square of all the elements of 2. So if I type this, MATLAB gives me an error, and it says that incorrect dimensions for raising a matrix to a power. So MATLAB is trying to do a matrix multiplication. But what we want is actually, we want to take the square of 0, take the square of 1, take a square of 2, and so on, individual element by element squaring. So how do I tell MATLAB to do that? For that, yes, you're right. Yeah, we have to put this dot here. So this dot will tell MATLAB that don't try to take the square of the whole matrix, do it for each and element individually. And this is how I get this answer. So how do I now, this is a square function, and we would like to maybe see the pattern between the two. So one way of doing that is, if there is a plotting function in MATLAB, which is scatter. So if I type scatter, I put X, then I put Y, and then I type this, and I get this very neat diagram, scatter. So X is on the X-axis, Y is on the Y-axis, and you see this is the behavior of a parabolic square function like you expected. I could do another type of plot as well, which is plot X comma Y. That is the more common type of plot that you generally see for engineering applications. And if I now again try to plot scatter, so you see now the previous one has been overwritten. So if you don't do this, if you keep on plotting, it will keep on overwriting. So what I could do is I could put I type figure, so that will open up a new figure, and then I do plot. So now I have two figures, and one is showing me the scatter and the other is showing me the plot. Yes, you could say scatter is point by point, and plot is, it also basically fills the in between. It is because, you know, we don't have values for 3.5, for example. But when you do the plot, so you could say it is interpolating between those points as well. And what if I want to do both of them on the same figure? So I plot, and then I write something which is hold on. Hold on tells MATLAB that on the same figure, don't overwrite, but make on top of this, both of them should be shown. So this is how I get that. So now you see, after putting hold on, now I have scatter as well as plot both on the same diagram. So scatter is the points that I gave it to MATLAB, and plot, the blue line, it is actually also between the lines, it is also correcting the points. So it is more convenient for you to sometime see this kind of, or to analyze this kind of diagram. So grid and Y label, yes, these are some you could now MATLAB in later in current versions of it, you could actually change these values as well. So you could grid on, grid off, you could do a lot of things there as well. So what if now we were doing everything on the MATLAB screen here right now, and now since we are going to just stop within a minute, so let me very quickly write a program so that you see now when I will close MATLAB, everything will be gone here. So the solution to that is open a new script like this. I will write clear all the previous variables. CLC clear the screen. Let's quickly write the function that we are writing here. So from 0 to 10, and then I write y is equal to x dot power 2, and then scatter plot, scatter x comma y, and then I say hold on. so don't overwrite, and then I simply write x comma y. Then I save this and I call it maybe example 0, for instance, and by default Matlab saves it as an M file. So I'm going to save this and then I'm going to run it. So you see there is a big green run button. I just run it and Matlab runs that code, and there it is. So it was already open, so let me run this once again maybe. So this runs it. So the benefit of this M file is that now next time when I close Matlab and then run it again, so of course this file will be saved on hard disk. So I will just open this up from here. This is in the same folder. I click this, I open this, and my commands are already there. And this is, you could also say this is my script. So I could run it again. I could make changes here. I could maybe change the range here as well, go from -10 to 10 maybe. So this is a more convenient way of running Matlab scripts. So you see every time this is going from -10 to 10. If I want to close this figure as well, so there is another command here which is close all. So it will close all the previous figures and then start from here as well. I could do also a cubic equation here, and that's the cubic function. So I wanted to stop at this point because I would tomorrow inshallah we will start from the same script, but we have discussed a few plots and I will inshallah make these lecture slides available to you. So before we start our tomorrow's session, I would like you to try this very small assignment. Everything is written as an English text, and please, we have actually finished our first script as well. So the things that we've discussed today, they should be enough for you to implement this very small assignment. So tomorrow, inshallah, the first thing that we'll do is that we will discuss this implementation. So please try to do this and share your thoughts the first thing when we start tomorrow. So I will ask the organizers to please take the slides from me and then make them available for everyone to see. That's it. Thank you for attending. If you have any questions, you could send them right now, or you could send them on my email or my WhatsApp even, and we'll see inshallah tomorrow. Assalamu alaikum.
Thank you, Doctor, for your effort and time for today, and see you tomorrow, inshallah. Nice to meet you, Doctor. والآن قد وصلنا إلى نهاية اليوم الأول من هذه الدورة الشيقة، ونود أن نوجه شكر لضيوفنا الكرام، ونلقاكم بإذن الله غدا في اليوم الثاني والأخير من هذه الدورة. اربطوا الأحزمة، موعودين بحماس جديد بإذن الله في الغد، وبإذن الله حنرسل رابط التحضير بعد دقائق حنرسل رابط التحضير، وموجود في رابط التحضير خانة جديدة أو قسم جديد للتقييم. تقدر أنك أنت تقيم الدورة، وتقدر كمان أنك أنت تقيم الدكتور والأمور هذه، وفيها أنك أنت تقدر أنك أنت تضيف بعض الاقتراحات أو أنك أنت تتكلم عن بعض الملاحظات اللي أنت قد شفتها. نشكر الجميع، نرجع ونشكر ضيوفنا على الحضور، وشكرا على وقتكم الثمين اللي أعطيتونا إياه. السلام عليكم ورحمة الله وبركاته.